Hello guys, welcome back to this channel Learn for Tech, and today we are on ARP, Address Resolution Protocol. ARP is one of the most important protocol of the network layer in OSI model, which helps in finding the MAC addresses given the IP address of the system. This is our network topology. We want to ping from the source 1 and C1 to the destination, the server 0, and we want to see how the packets move or assist the devices to move packets from one device to another. And we have this device switch and the other devices, as you can see here. Now let's try to see how the ARP works at the network layer. When the source, this source wants to find out the MAC address of the destination device, it first looks for the MAC address or the physical address in the ARP cache or the ARP table. So when you want to ping from the source to destination, we must have the ARP table or the ARP cache which have the details of other devices. So now let's check how to check the ARP table or the ARP cache. You just type ARP-N, but you can see here our entries, we have no entries. Our entries are 0. We don't have entries, so we don't have the ARP cache or the ARP table. What will happen if we want to ping from this device to this device if we don't have the ARP table? So if the ARP table is present there, then it will use the MAC address from there for communication. But if the MAC address is not present in the ARP table, like here, like on our topology, then the source device will generate the ARP request message. So let's now try to ping and see how it works. From the source to destination is 1, or the target is 192.168.1.2. Let's try to ping. (192.168.1.2). Now you can see we have two packets. One is SMP, the purple one for the pinging, and the blue one is ARP. This is the ARP request message. So in the request message, the source, let's open it, the request message. So in the request message, the source C1 puts its own MAC address. You can see the source MAC address, its own IP address. You can see the IP address, the target or the destination IP address, as you can see, and the destination MAC address is left blank since the source is trying to find it. We don't know the target MAC address, that's why it's blank. And for the network layer, we have to know the MAC address of the target device for communication. Now let's see what will happen. Let's run the simulation. Now the source device has broadcasted the ARP request message to the local network. As you can see here, each device has received the ARP request message. the broadcast message is received by all other devices in the LAN network. Now each device will compare its IP address of the destination with its own IP address. The target IP address is 192.168.2, but each packet, each device will do the comparison. If the IP address of the destination matches with the device IP address, then the device will send the ARP reply message. If the IP address don't match, then the device will simply drop the packets. As you can see here, the packets are dropped because the target IP address doesn't match with the device IP address. But here the packet has been received. Now the device whose IP address has matched with the destination IP address in the packet will reply and send the ARP reply message. Now let's see. We have the ARP reply message here. This ARP reply message contains the MAC address of this device. The destination device updates its ARP table and store the MAC address of the source, and it will need to contact the source soon. Now the ARP table has been updated here, and the source becomes destination or the target for this device, and the ARP reply message is sent. Let's open the outbound. Now for the ARP reply message, the target or the destination becomes the source. That's why you can compare here. The source MAC address is the same as this one. The source IP is 192.168.1.2. The target MAC address is, as you can compare, and the target IP is 192.168.1.1. And we should note that the ARP reply message is a unicast. The ARP reply message is a unicast, and it doesn't broadcasted because the source which is sending the ARP reply to the destination knows the MAC address of the device. Before we had a broadcast because we didn't know the MAC address of the target, but now it is a unicast because we know the target MAC address. So let's run the simulation. As you can see now, the source has now, this PC1 has now, it now has the record of the server. It has the record of the MAC address and the IP. That's why it has been received. So let's try now to run the simulation again. As you can see now, when the source received the ARP reply, it comes to know about the destination MAC address and also updates the ARP share. Now the packets can be sent from the source to the destination or to the target. Now this packet is a SMP or the pinging. We can ping because we know the target MAC address. We can open the SMP. As you can see now, the source IP is 192.168.1.1 and destination IP 192.168.1.2. And we know the MAC addresses. Now we have the reply SMP message that I'm acknowledging your request. From here now we have the communications. Now let's run the switch. Now let's run the switch. Let me check the MAC address table. Show MAC address table. As you can see here, we have now the records of what? Of the devices. For this MAC address, which is this MAC address, on the MAC address table we have the record. When you want to ping or you want to access the server is in VLAN 1, and this is the MAC address. The type its LAN is dynamic and it's connected to port FA0/3, as you can see. And if you want to access PC1, it is in VLAN 1. This is the MAC address and it's connected to port number FA0/2. Now this is the MAC address table. So next time if you want to ping from the source or from PC1 to the server, there's no need for broadcasting because we know the target MAC addresses. Thank you guys.